voice. It's never happened to me before. So this is about as loud as I'm going to talk. So if you can't hear me, move up or tell me to get my face closer to the mic. A bit of a grim day today, but I will do my best to make it worth your while coming out. So, a little bit about myself before we get into the presentation. I'm a retired water engineer for 20 years with the US Geological Survey, and I received some of this climate reality leadership training a couple of years ago. And so I'm not an expert, but I'm a concerned citizen. And additionally, I'm a recent grandfather. That's Jack, who was born about a year and a half ago. And you'll see a little bit more about Jack in the end. So, can you hear me okay? We good? Okay. So, really two things today. I would like to, the training I took, they asked to pass it along, and that's where quite a few of the slides are. But then, I'm going to have some questions where I'm looking to learn from you. And this first slide, and it was taken during the Apollo program there in the 70s, and from the moon looking back at Earth. And to me, it just shows how finite and how beautiful the Earth is. I think most of us have seen that image. So the three things today is when you talk about, must we change, and then can we change, and then, will we change? And just a touch of science here. So the radiation we receive from the sun for millions of years, it's been going on where about half of that is absorbed to the Earth's, half is absorbed into the Earth's surface, about a quarter goes back out to space, and about a quarter is in that layer of our atmosphere. It's been going on for millions of years. So about half back out, half absorbed on the surface, and a half into our atmosphere. But in the years since about World War II, we've been putting much more carbon in the atmosphere, and it's like thickening this insulation blanket. So the atmosphere is holding much more heat than it used to. And we're putting quite a bit in our atmosphere. In fact, the amount of heat that the extra carbon is retaining, that's the heat of about 600,000 atomic bombs per day. That's the amount of heat that we are retaining extra. And it's really a fairly thin layer. This is a view of our atmosphere. So this carbon that we're putting up in the atmosphere, where's it coming from? Well, it's from underground. It's the coal that's coming underground, oil that's used for diesel and gasoline, and methane. And our transportation uses about 30% of the fossil fuels. This graphic shows how things have changed. In other words, so this is time for about the last basically 170 years, and you see the increase of, this is tons of CO2. The amount of CO2 that we're putting up there really has increased since about World War II. And what is this? What makes up those fossil fuels? About a third is coal, a little more than a third is crude oil, and then natural gas. But you can really see how it is increased after about World War II. These next two graphs I'm going to spend a little bit of time on because to me they're really important. This axis here is time, and we're going back about 10,000 years. If you go back 11,000, that was when the last ice age ended about 11,000 years ago. This is when civilization started to form, we started coming together. This axis is the amount of carbon dioxide in our atmosphere. And you can see that over the 10,000 years, it went up and down a little bit. It would go up, volcanoes put carbon out, so you see it go up a little bit. You see it go down vegetation and trees uses carbon dioxide. So if we had a period in our Earth's history where vegetation kicked up, you'll see it go down. So you see it oscillate up and down, but it goes between essentially about 270, 280 here. And then since World War II, you see it shoot up to about 420 right now. So you see it oscillate some, but then it rapidly shoots up to about 420. And you can take a measurement of carbon dioxide as simple as you can take your temperature. It's a very easy measurement now. How did we do it 6,000 years ago? You can see up there ice core data. I work for the US Geological Survey. Part of the USGS takes ice cores at the poles, and you can, from those ice cores, you can determine what CO2 was back. So does that make sense how it oscillated naturally? But this portion is not natural. So I'm going to do one more graph that's tied into this, but the point to take away from this is how it oscillated at about 270 or so, but then shoots up to 420. I'm going to blow this period up, and that's what this graph is. So this graph is since about World War II, and there's two things plotted on here. One is carbon dioxide, that's this yellow line, and here's the value again. It was maybe about 280, but it goes up to about 400, so that's that carbon dioxide we saw. Does that make sense? And the other plot on here is global temperature. And when it goes down or goes up any given year, that's weather. The weather varies. But climate, which is the longer string of weather, you can see how the temperature follows the carbon dioxide. Does that make sense? So the other thing that's worth thinking about for me is, so the Earth is complicated, but the actual principle of carbon dioxide being like an insulating blanket holding heat, you could do that, we could do that in this room. If we took two bottles, and one of them we just filled with the air in this room, and the other bottle with carbon dioxide, put a heat probe in each one and put a heat lamp on, the bottle that had the carbon dioxide heat up faster and hold more heat. So it's just a simple experiment for that principle. So what happens when you end up having this extra insulation in our atmosphere? Well, if you take the average temperature on Earth from 1880 to the present day, which years were cooler? It's these years. Which years were warmer? Were the red. So when you create a larger temperature, we all recall the drought we had in the Pacific Northwest, and there were some health, these are hospitalizations out there in the Pacific Northwest due to heat. And you know, the heat is toughest on the poor and the elderly and younger people, people with medical conditions, mentally ill, and agriculture workers. And it's felt that if we keep going the way we are, that agriculture is going to be difficult in the southeast. Another place this extra heat goes to are oceans. And if you take the average temperature over 60 years, which years were cooler? Ocean temperature. These, which ones are warmer? So again, a pretty clear pattern. And when you have warmer oceans, you have stronger hurricanes. When Hurricane Ida, August 21, went through the Gulf, it was 7 degrees Fahrenheit warmer than normal. And you know, it continued up the coast of the U.S. and there was over 80 fatalities. And I think we're familiar with the damages that occur from hurricanes. I'm just going to pop through a couple of these slides where I think we're used to, seeing that. And this is a shot of an amusement park in New Jersey from Sandy Hook and from Hurricane Sandy. Texas from Harvey received 5 feet of rain. And one of the things that happens when you have a flooding along the coast, a lot of our refineries and chemical industries are there where you have the releases, and a lot of those areas, for one reason or another, are where low-income and minority communities live. And Guatemala and hurricanes are affecting people overseas also. And hurricanes, warmer water leads to more intense hurricanes, and they intensify more quickly. And warmer air can hold more moisture, so you'll have heavier downpours. So when you have extreme weather, it's tough on our infrastructure. I'm not going to go through all of these, but it costs us all money via insurance and the cost of replacing this. Just a shot of a road damage in Michigan after. So as you increase more moisture from the oceans, you end up with, and this is a video from NOAA, concentrated moisture in the atmosphere. I think we've been hearing it somewhat on the weather now. Weather people talk about atmospheric rivers, so basically concentrated moisture. And when you have that, you have intense downpours. This is, in fact, I think sometimes they call them rain bombs, but intense rainfall that occurs. And again, you have a flooding from intense precipitation that doesn't have time to infiltrate in or run off on the surface. So, and this is a shot of Venice flooding and intense flooding in Italy. So Europe is experiencing something similar, and so is China. China has had some very intense rain, and this event cost 300 lives. So a couple of years ago, I had a temporary assignment to go measure the amount of water going under and around bridges during a flood on the Red River. And it was amazing. And I saw an area flooded where just the tip of a barn was sticking out. It was amazing what this was the Red River pre-flood. This was during a flooded period. And of course it takes its toll on agriculture. I think here it's a shot in Nebraska, and that the flooding in the year of 2019 caused $20 billion of damages. So it's costing our agricultural community money. Also, India had 1,900 deaths from an intense rainstorm in a couple of years back. Just a little bit about tornadoes. So scientists have a difficult time representing tornadoes with equations and modeling. The scale is quite small, but what they're finding is it appears that clusters of tornadoes, with the warmer temperatures we have, we're seeing more clusters of tornadoes, but it's a difficult phenomena to model accurately. And this extra heat that pulls water from the ocean, it also takes it from the land. So as a result, we've had a drought in western U.S. here, and the Lake Mead behind Hoover Dam was as low levels as it was since it was initiated. And Brazil, the droughts are overseas also. Brazil had quite a bit of damage due to drought, and Europe's groundwater. You don't have the amount of precipitation coming down you normally would have. Groundwater levels have reached low levels in Europe. Fires. You end up having more fires in the hotter years. And scientists have studied this fairly intensely here recently, and for about every 1.7 degrees Fahrenheit of warming, you get more lightning strikes, 10%. And these lightning strikes have caused fires. So this is a bit of doom and gloom, right? But hang with me for about another 5 minutes, because there really is, there's hope here. We really can solve this. But it's if the effects of that extra carbon, and when I say carbon, it's carbon dioxide, methane is a CH4. So the extra carbon has a lot of different effects. But hang with me for a little bit of this grim stuff for a little bit more, and then I'll get into really what we can do about it. And California, if you took their 6 largest fires in their history, 5 of them occurred here a couple of years ago. And I have this slide in because we just can't make this acceptable. You see some people playing golf with fires in the background. We can't get used to it and say, hey, this is going to be life. And Spain has had increased fires, and so we've affected the hydrologic cycle. The amount of water that we evaporate from the oceans and land now is different than it has been, and the type of precipitation comes down more intensely. Some areas of the globe are going to have less precipitation. Some are going to have more. And scientists have really improved in predicting which areas of the globe are going to have changes in precipitation. Department of Defense has said, the change is going to lead to different shortages of food and water and some disease and refugees. And I have this shot in. This is the shot of Syrian refugees in Croatia, and I was actually in Croatia traveling in 2015 and was on a train with about a 1/3 of the amount of people in this, and I just assumed it was the political situation in Syria, but a portion of the refugees were due to drought. They had had a severe drought, and they had lost over 50% of their farms. And this slide is in that here in Central North America, if we keep doing what we're doing, it's projected there's going to be an extremely dry area there in Central America. That's what they feel to be the most drought-affected area. And Honduras is ranked to be one of the most affected countries. And that will increase refugees on our border, right? So a touch of science yet. Our climate, we move temperature from the pole, from the equatorial area to the poles, so that 1 degree of change at the equator results in about a 3-degree change at the poles, and that temperature movement sets up the ocean currents and the air currents. And it's unknown that if we keep warming, how those currents will change. And I'm going to say an extra word or two about that. If you've heard of tipping points, sometimes you'll hear about that in the press, tipping points. And a tipping point is something that happens rapidly over a short gradient. So you can think of the freezing of water. It doesn't freeze at 50, it doesn't freeze at 40, but it freezes rapidly at 32. So it's a tipping point is something that happens rapidly, and with these ocean currents, it's not clear. And these ocean currents are, I was in the Coast Guard in Miami, in the Gulf Stream. When we have search and rescue, we take into account that they're going to drift up that way, and those ocean currents affect the temperature in Europe, and also it's uncertain as to what point that may change. Science does not have a good handle on that. A little bit about glaciers. So this is a shot of in Greenland in 1935. You can see the tongue of the glacier here. And if we take the same area in 2013, you can see it's really receded back, and an actual plot of it that shows the declining ice mass in Greenland for the last 20 years. So I have this shot in because I was in Peru about 10 years back in a little mountain village, and the local farmers, to water their crops, the summer they get melt from the glaciers and they use that for irrigation, and then in past years the glacier would rejuvenate in the winter. Well, their glacier was almost gone, and they really didn't have an alternative. There was not a way for them to irrigate. So it is going to affect people in many different ways. So this is a shot of, I was on a buoy tender icebreaker in Sturgeon Bay for a couple of years. We're coming back from a winter deployment, and this is a shot of pancake ice, and I have it in there because ice is important at the poles for wildlife and ecology, but it's also just plain beautiful. So a touch more of ice. This is a shot of the North Pole there in '84, and you can see how it has shrunk in size. This is a graphic of the aerial extent of the Arctic ice, and you can see it fluctuating there for most of the 1,500 years, but you can really see it take a dip. And with that, oceans will be rising, and the cities around the globe that are most at risk, Miami is there, in New York, and New York has quite a bit of real estate now. It's in flood zones. Kiribati, a South Pacific nation, due to the rise in the seas, they've had to relocate some of their refugees and actually their citizens and purchase land from another country. And the World Health Organization has said that climate change is a health threat. And the Pope has said repeatedly that difficulties with the environment are oftentimes suffered most by the poorest folks. So the climate affects our food supply. We've talked about some of that. It also, and the British journal, The Lancet, has mentioned that it's going to be a health concern this century. I'm not going to talk about these health areas other than air pollution. I'm going to mention a little bit about that. Air particulate, globally, about 9 million people die per year from air particulate. A lot of those folks are urban folks and younger people. And I mentioned coal because coal is a source of particulate, even with the scrubbers, you get particulate coming out. But coal's kind of a triple whammy in that a coal plant will take coal that's carbon that's been buried for millions of years, burn it and release it to the atmosphere. So one thing, it's taking carbon that's been down there, bringing it up. It's also releasing particulate. And then the other thing coal plants do is there's mercury in the coal, so it's releasing mercury to the atmosphere. And I had a colleague at the USGS for 30 years. He studied atmospheric deposition of mercury, like in our lakes, in the oceans. His name was Dave Krabinoff, so he had projects in the Yukon and around the world. So atmospheric mercury, coal plants. And this slide just shows that the ocean mercury has increased. And I think most of us know that, if you're a woman of childbearing age or children, you need to be aware of fishery. So that was a lot. But this slide, basically, I just want to get across that the cost of carbon is a lot. And for me, I think it's not an acceptable cost to pass on to the next generation. So I come back to this slide a little bit because the Earth system, it's complicated, but just the concept of carbon being insulation is not a difficult thing to establish. So must we change? Yes. And can we change it? And here's the part. It's good news. We're not doomed. In other words, we can't dawdle anymore, but we have we have the solutions to fix this at hand. We just need to do it. It was felt up until a couple of years ago that if we stopped globally right now putting and keeping our concentration of CO2 where we're at 419 or so, it was going to keep getting warmer for like 30 years. But a number of scientists have disproved that that if we can hold where we are, that within as little as 3 to 5 years, that we're going to halt the changes. And that's mainly because they understand now that oceans can sequester more carbon than they thought, and also vegetation. So how are we going to do it? One, and it's not going to be one technique that's going to do this. It's going to be a whole range of them. But if you take a look at wind, it was felt in 2000 that in 10 years, the wind capacity would be 30 gigawatts. Well, in 20 years, that was exceeded by a factor of 24 times. And the cost of wind, has come down. This graph just shows how dramatically it's come down in the last 12 years or so. And so we are producing more energy due to wind. Germany produces, this was 3 years ago now, over half their electricity is from solar and wind. And of all the electricity we use globally, wind could supply it 40 times over. But of course, it doesn't always blow, and you have to store it, right? Another approach is solar, and solar, was felt that in 2002 it would grow by like 1 gigawatt. In the next 8 years, that was surpassed 17 times, and 18 years later it was surpassed 130 times. So the cost of solar has really come down. And as the cost has come down, the amount of capacity, that amount of panels we are way up. And I have this, it's true for overseas. Australia now, 1 in 5 homes have got solar panels. I have this shot in because it's just a mixing of agriculture and solar. You can see in the upper left you have a sheep grazing between the panels. Lower left, livestock sheds got panels on top and doing some vegetation between the panels. And the lower right one is an urban setting where you've got solar panels in the middle of a freeway with bicycle passage, under them. The Vatican is using panel. In fact, the Vatican is, I think, a net zero with carbon right now. I have this one in. If people, when we're done, I've got some panels on our house. If you're interested as to details of it, I'd be happy to talk to you about it. And if you take the world's energy needs for a year, we get that amount of energy every hour. So we're not going to run out of solar. But again, sun doesn't always shine. You need to be able to sometimes get where we have a lot of solar to the cities, so you need the distribution network. But there is a lot of energy coming down the earth via solar. One of the things we have to do is store it. And this shows the storage for about 10 years storage capacity. This is globally how it's projected to change. So these were the 10 years right there, but that's how it's projected, the storage capacity of electricity. And this is a shot of was a natural gas power plant. It's now a battery storage project, the largest one in the world. It's in California. Another large storage facility in Texas. And this graph, it just shows a little bit of how we're making electricity right now. If you take a look at, this was coal, and you can see it sort of peaked in about 2005, and this is the energy from basically solar and wind renewables. So they're about equal right now. 2 are unequal. When I took the training, a couple of things really surprised me, and this was one of them. This shows the cost to get electricity from coal for the last 10 years. And you can see it's pretty level, right? That's the cost of getting electricity from a coal plant. That's the cost of natural gas, and it's gone down. It's a little cheaper. And you will hear it presented that natural gas is the clean way to go. And that's true in that it doesn't have particulate like coal, right? But natural gas, you're still taking carbon that was down underground for many years, and you're bringing it up. So the cost of nuclear has gone up some for a number of reasons. That's the cost of wind, it's come down. And that's the cost of solar. So right now, if you're the CEO of a power plant and you need, or of an energy company, and you need 25% more energy for your company, it's just plain cheaper to do it with wind or solar than it is with the fossil fuel, the natural gas or the coal. It's just, in the US, it's just plain cheaper. I show this one just to show how dramatically, let me see if I can go backwards. One more. So this is for, if you look at that bottom scale, that's for about 11 years. I'm just going to go back much farther in time, and you can see how rapidly solar has come down since the 1970s. You know, a couple of statements from people in the business. This public service CEO has said the surprise has been how dramatically renewables and the storage of renewables have beat natural gas. So you wouldn't have predicted it, 5 years ago. And this CEO has said, there's not a coal plant in the country that's economic. But the coal miners didn't bring this on. It needs to be a just transition. But moving to renewables, the wind and solar, it's going to be safer. I mean, if you think of the Massey coal mine accident there in 2010, that took the lives of 29 miners. I have this shot in because my son was in the Coast Guard, and that Deepwater Horizon spill years back where it blew up and we had the 11 deaths on the platform, and my son Casey down there was on the cleanup, and 3 million barrels of oil. I mean, it was quite the disaster. So renewables will be safer for humans that are working on it and for our environment. And there are more jobs in the US right now in solar than in coal mining. And China is putting in more solar than any other country in the world. They're still burning coal, but they're putting in more solar than anywhere in the world. And globally, there are a lot of renewable energy jobs. Another thing that I hadn't thought about before I took the training was this, that renewables have an opportunity to be energy opportunities or energy justice for portions of the world that have not had power before. You have countries that don't have the stable government, you don't have a stable utility where they just didn't have power. But now the solar panels, it's pretty simple. You don't need a big infrastructure. You put a panel up and maybe a battery for some storage, and when I look at that panel, it's like one we had on, Amy and I had an RV, and from that panel, it ran our water pump, our refrigerator, computer electricity, the lights, So this is just another shot of solar that's being used locally. So it has the potential to bring power to areas that didn't have it before. And a lot of countries, companies are going renewable. This is just a listing of international companies that have pledged to go renewable. Auto manufacturers are moving to electric vehicles. That's where they see the profits. Oops. Let me go the other way here. So GM has said that it's in their interest to go electric, and that after 2035 they're not looking to produce gas or diesel passenger vehicles. Volvo, in 7 years here, are going to be all electric. When you think about that change, the change where we went from horse transportation to cars, in the US that took about 20 years. I think a lot of it was done in 10, but anyway, that was a transition that we went through. And if you guys are, and I do have a handout here of some of these slides, but if you're interested in electric vehicles, if you just do a quick Google on Hertz electric vehicles, the Hertz rental folks, they've got some really readable, consumer-friendly info on their website as to what electric vehicles are about, how you charge them, that kind of stuff. So it's a, Tesla is looking at semis being electric. So the growth of electric cars have been dramatic globally. This shows it, the growth over the last 10 years. And there are countries, and you can see the state of California, that have said they're going to phase out fossil fuel vehicles, and you see Norway is looking at doing it in a couple of years. So a couple additional solutions besides the wind and the solar. Agriculture is going to be a real piece of it. If you can use an agricultural approach, whether it's crop rotation or limited or no-till, where you keep vegetation on the ground for much of the year, that's going to have a substantial effect on pulling CO2 out. I don't know a lot about regenerative agriculture, but I do know it's going to be a substantial piece of the puzzle going forward. And conservation tillage is growing, in the U.S. I have this slide in because the steel mill in Sweden's been operating since 1604, and they use green hydrogen to heat in their mill. And what's green hydrogen? Green hydrogen is, if you take water and you apply electricity, you'll split water into hydrogen and oxygen. A very clean process. And that hydrogen then, and the electricity that you split the water with, if that comes from solar or wind, you're not using any carbon in it, right? So the electricity that you use to split water into hydrogen and oxygen, if that's from wind or solar, it's totally not dependent on fossil fuels. So hydrogen is used to produce steel in this plant, and hydrogen would be a good way to store storage. I have this, and if you do a search on Project Drawdown, they've got a list. They're a nonprofit with researchers employed, and they've got about nearly 100 solutions to what we can use going forward. And again, I mentioned it's not going to be one thing. Another aspect of the training that took me by surprise was this. The agricultural revolution took about 6 or 7 centuries to go from where we were hunter-gatherers to growing crops. The Industrial Revolution it took longer. I think it was about 100 years, the using of machinery. So the digital revolution has occurred in about 2/3 of my lifetime. In college I used the slide rule, right? So the digital revolutions happened quickly. It's felt that the sustainability revolution really could be quite fast, because it's using a lot of what we developed during the digital revolution. So, can we change? Yes. And one reason that makes me confident we can is this slide right here. It's just cheaper in the US right now to use non-fossil fuel for energy. Again, that's not going to be the only solution globally. but it's just plain cheaper, which I had no idea that was the case. So will we change? Well, we're part of the Paris Agreement, and there are communities around the country, local government, that have pledged to go renewable. There are some local governments that have achieved 100% renewable electricity. And I think we all know about the Inflation Reduction Act that was passed, and so we have the ability to do it. The question is, will we do it? And we have to do it fairly rapidly. So have we ever gone through something of a major scale that rapidly? And an example is AT&T back in 1980. They projected cell phone users of under 1 million in 20 years. Well, they missed it by a factor of 120. It was actually in 20 years 109 million. And now there's 100 times more than that. There's 10 billion cell phone users. So they weren't only wrong, they were really wrong. Why were they so wrong? Well, partially because the cost of phones dropped sharply, and the cost of panels have dropped sharply. The quality of the phones increased dramatically, and the quality of solar panels have increased dramatically. And here's, again, one I hadn't thought about, is the low-income nations with they didn't have the stability to have phone lines. So they didn't have the typical phone that we had. Well, they really jumped on board with the cell phone. This shows the amount of cell phone usage for 30 years in developed countries, and that's the cell phone usage in undeveloped countries. It just blew it away. And that's because they didn't need to have the phone lines. And I think solar has the capability to be very similar. And you don't have a complicated system to set it up. You've got low initial cost. This is another shot of solar in a remote area. So a lot of these slides were provided by the training, but I put some in myself. And this one was from Time Magazine, who had said last year was kind of the year that people, organizations, and governments started to come together. And the examples they gave was the auto electric acceleration and wind green power. Europe and China really have used it quite a bit. We have one large offshore project. And there is some development out there, Iceland being one, where they're actually removing carbon from the atmosphere and going to be putting it back locked in underground. Batteries are really changing. Scientists have a much better understanding now than they did a couple of years ago of how the physics of it is all working and how it's playing out globally. And coal generation is being phased out. So young folks are asking for a cleaner, safer way of doing things, both here in the States and around the globe. So I'm really asking 3 things of you today, and I'm just going to pass. If you just want to pass them around. But really 3 things. One is use your voice. And what that means is talk to your friends, your neighbors, your family. I know in some cases it's not an easy subject to talk about, but just talk about it. And then when you vote, not asking you to vote Libertarian, Republican, Democratic, but if you have a primary with 3 candidates and one candidate is talking about trying to limit the carbon we're putting up there, give it some thought. And then your choices. In other words, we all can't put solar panels on our roof right now. We all can't get an electric car, but we can insulate our hot water pipes. If you don't need to idle your truck or your car, don't idle it. Home insulation, all of that is pertinent. In my way of looking at it, it's really important for the next generation. This is a shot of my family, my wife Amy and our 3 adult children, and Beth. Beth got married about 3 years ago, COVID, and she's the one that has Jack. There's a shot of Beth and Mason. So I've been doing this now for about 2 years, where I'm passing forward the information I learned, and I'm doing it for really 2 reasons. One is because I think it's important for them to get folks talking about it and thinking about it, and then I'm really looking to learn from you all. And one of the questions, well, a couple things. One is, if you have any questions or want to, my email's on there, please email me. But I'm interested, after seeing this and after what you've picked up in the press or your neighbors, if you don't feel that we have done something to our atmosphere and that we need to do something about it, what it is that would cause you to think that. In other words, to recognize that we have changed our atmosphere. Do you need to see the ocean rise 2 feet, or do you need to see the temperatures here in Wisconsin be 110 for the month of June? What is it that would cause you to realize that we have made that change? I'm very much interested in that. So, with that, and also, I'm going to do this for another a few months yet anyway, go out and pay the information forward. So if you know of a service group or a business community or something that might be interested in this information, doesn't matter if it's 3 people, 30 people, please let me know. You've got my email on there. So anyway, I'd be happy to take any questions now, or like I say, I'm not an expert, but I've both in my job I was exposed to it and trained. So yes.
So you had mentioned that the dramatic increase in carbon emissions happened after World War II. Can that be attributed directly to the increase in population during that time? From that point forward, basically the baby boomers and just the whole population went. Is that the single factor, or are there others that help to contribute to that, or? Right.
So the question, I guess you all heard the question, right? I'm not an expert on it, but this is what I think the answer is. It certainly is due to the increase in population globally, right? Because this CO2 that I show you, that's not that plot of where for 11,000 years it went like this and this from the natural plot, and then all of a sudden you see it dramatically shoot up. That's globally, so it's not just the U.S. But yeah, it's certainly that the amount of people have increased, but the amount of carbon we're using per person has also gone up. So it's both.
Okay.
It's both, and again, like I say, it is global. But I heard a presentation from a researcher. I think he was Stanford, and he had a staff of about 5, and I'm not recalling his name right now, but he's a person that does projections for the future, and that's what his research is. And he's projecting that renewables can make electricity extremely cheap in the future. That it's going to be. We have to make decisions to go that way now. But the way he envisioned it, he sees power being extremely inexpensive, both here in the States and globally, and that will actually decrease the cost of our lifestyle somewhat. So anyway.
Another question?
For sure.
Okay, you had mentioned that if the carbon forms a layer above the earth, is that what is contributing to the ozone layer, the depletion? Or how does that work
Right,
together?
okay, so I haven't been trained in ozone, but just picking up as a layperson, no, it's separate. You know, the ozone was from, I think, different refrigerants, and it was so the source of ozone is different than the carbon, you know.
Okay.
And again, that rise of CO2 in the atmosphere, it is from us bringing carbon that's been underground for so many years, that being coal, oil, and methane. And all of them, when you think of methane, that's also carbon, because methane, the chemical makeup is 1 carbon and 4 hydrogens. And when methane goes up in the atmosphere, natural gas, and you've also heard about, you know, methane from animals also, right? When methane goes up, it's even a little bit more efficient, a tougher insulator than carbon dioxide, but there's much, much less there, and over time, that methane, that CH4, will break apart, and the C will combine with oxygen to form carbon dioxide. So it doesn't stay methane forever, and that's probably more science than you wanted to know, but the methane doesn't stay up there forever. So.
I just was going to add, one of our sons had lived in Duluth and now is living in Grand Marais, and he often will talk about the climate refugees that have come to that area from the West Coast, and they typically are white, you know, they're educated, and they're not very appreciated by the locals. So, I mean, it's kind of like not wanting somebody that comes that looks a lot like who's already up there. So it was just his observation in the last 10 years has been interesting.
And those are folks coming from the Pacific Northwest, you said?
Well, the West Coast.
West Coast,
West
yeah,
Coast,
right.
yeah,
Right,
yeah.
yeah.
So it just
Yeah.
kind of newer to us.
Yeah. Well, you know, and and also if you, you know, afterwards, if you want to tell me privately or send me an email, as far as how this could have been more useful to you, or, I mean, it's a, you know, things are happening, and I think the science behind climate is for a lot of folks now not political anymore, you know, the science behind it. The solutions are going to be, you know, I mean, in politics, that's us interacting, right? And the solutions, I mean, you can even look at it globally. A country like Kiribati, who probably hasn't put a lot of carbon up there, but they're having to move some of their folks because they're underwater. Well, do they get subsidized or help from somewhere? I mean, it's those kind of questions, you know, that are not going to be easy. But the actual, the physics as what's been happening, that's really clear in the scientific community. I mean, you'll get every now and then you'll get a scientist or something, but that will put out a paper, but they're not peer-reviewed. I mean, peer-reviewed papers, it's really important. When you pay attention to something, pay attention to, you know, a paper that's been peer-reviewed, because it's been reviewed by other experts, and if the research that's in that paper has to address stuff in the past. So there's it's important to look at peer-reviewed stuff, not something that a person just goes off and writes and doesn't have it checked, you know. So anyway, well, thanks.
Thank you.
Your voice lasted.
What's that?
Your voice lasted.
It did actually. It's pretty darn good. You know, like I say, when I woke up this morning, I couldn't speak to my wife. You know, I had no voice. So.
Well, thank you.
Thank you very much.
Yeah, no, my pleasure.